Hey guys, my name is Daniel Porter, and I'm going to talk to you about how ship engines affect aquatic wildlife. So, brief overview is I'm going to start with vibrations and those effects on marine life and the effects on ships themselves, and then I'm going to move to how vibrations propagate in water, and then project plans. So, ships, when they operate in water, the engine and the prop shafts and everything else mechanical in the ships cause vibrations, and these vibrations propagate throughout the water. And what that does is it creates noises in the water, which affects how marine wildlife um, can, live and conduct their basic life cycles. And it can affect, as McCormick et al. Has found, um, noise influences the information based upon which behavioral decisions are made, which affects how fish can basically decide how to escape danger and basically, um, you know, live their basic lives. Also, noises can also affect where fish, you know, find their where they decide to um, where they decide to select their habitats, and it affects populations, and it also affects the resilience of, you know, marine wildlife towards it affects their resilience toward human interaction with them. Um, Basically, how to where humans interfere in their lives is what I mean. Their resilience to that. Also, it's believed that fish can sense vibrations, and it can direct their escape responses. Um, and it affects how they escape from danger, and it also affects how they communicate with one another. So um, some marine animals vocalize their they use they vocalize their own noises to communicate with other wildlife while foraging, um, and searching for food. And if you interrupt that, it's going to affect how they can find food and how they communicate with others where food is at, which is going to interfere with their population levels and whatnot. Also, marine animals, marine mammals, communicate with others, and they can only communicate over a certain distance. And so, noise from ships can actually interfere with that, and it's going to affect how far they can communicate with one another, and it can severely limit how their um, communication. So then I move on. So now we're going to analyze the vibrational effects on ships. So as engines and prop shafts, they're part of a mechanical system, and this mechanical system is made up of all different things: um, chain belts, duct flow vibration, shafts and supports, um, cylinders, pistons, all that kind of stuff. And all these things, when they're working, cause vibrations. And what these can do is they cause vibrations on the ship. And there's only a certain threshold that you want that you is okay for the ship to operate at. So um, and they're classified on two different levels. So the global vibrations are where you have the entire ship that's responding to the vibrations of the engine and the water passing over the hull of the ship. And then local vibrations occur when you're talking about an isolated part of the ship. So you're looking at one particular section of the ship, and then you're analyzing the resonance throughout that structure. So, and these vibrations can end up causing, and it can end up causing wear on the ship. You're causing a torque on the crankshafts. And the um, and the pistons, the crank that are working up and down. Over time it's going to wear, and if you have serious vibrations in those, which as an engine wears, it's going to more vibrations are going to be seen in the mechanical system, the engine. And that's going to cause vibrations to multiply, which is going to cause which is going to cause a lot more problems. That's going to cause wear on your engines and wear on your mechanical components. And when you have wear on your mechanical components, that's going to, it's going to cause more vibrations throughout the entire ship, and it's going to cause vibrations to, magnify in the water, which is going to greatly have a greater impact on wildlife. So, and so so if your ships are not well maintained, you're going to have a larger um, negative impact on marine wildlife. And there are certain systems that can be used to dampen those effects, such as motor mounts. And um, motor mounts, they're consistent. They're always trying to develop better ones that control more vibrations. Um, so if you can control more vibrations, that's going to limit your impact on marine wildlife. And also, um, there's a process called denoising source separation, which is used to identify the vibrations coming from your mechanical components. And if you can set a baseline for what vibrations you're looking for, then you can identify when your ships are wearing down, and you can keep them properly maintained and fixed components so that you're having a less impact on marine wildlife. So I know this is going to sound, which sound is a form of vibrations, but what I wanted to say here is that through water, vibrations propagate through various elements differently. So water compared to air has a higher viscosity, heat capacity, and conductivity of sound waves. So vibrations are going to, they're going to be muffled a bit more in water. And so what I want to do is see how vibrations, propagate through water, and how far they can propagate, to see how far the impact is of the ship vibrations. So what I'm going to do for my project is measure vibrations from a ship's engine and plot the propagation through the water, and analyze how these vibrations affect marine wildlife. And through that, I hope to better understand how human activity, particularly with shipping and sailing and whatnot, how that affects marine wildlife. And these are just a look at my sources. Um, if you have any questions, I'll post my my email in Moodle. And thank you for listening.